We're now moving into the trigonometric part of section 2.4 with the chain rule. Whenever it is we're differentiating trigonometric functions where there's stuff within the trig function other than just x, we need to apply the chain rule. So, the chain rule must be used when the angle has something else with it, such as y equals sine of 3x, or when the trig function itself is raised to a power. Let's jump straight into our first example. Which says y is equal to sine of 2x. Here's our stuff. It's not just plain old x. So that means to differentiate, derivative of sine is cosine. So the derivative is cosine of 2x times the derivative of the stuff, which is 2. Rewrite it. Y prime is equal to 2 cosine 2x. Next, b. We have y is equal to cosine of 4x squared minus 1. It's not just cosine of x, it's cosine of stuff. So, to differentiate y prime, derivative of cosine is negative sine. So we have negative sine of 4x squared minus 1. Plus, tack along by multiplying the derivative of the stuff, which is 8x. Rewrite, bringing that 8x out front. So y prime is equal to negative 8x sine of 4x squared minus 1. And the last problem within this section, we have c, which is y equals tangent of 3x. It's more than just tangent of x, tangent of 3x, so 3x is our stuff. The derivative of tangent is secant squared x. So the derivative of tangent of 3x is going to be secant squared 3x. But then we have to tack along the derivative of 3x of the stuff, which is 3. So the derivative y prime is equal to 3 secant squared 3x. Sometimes we have to be careful with parentheses when dealing with trig functions. Like our next example, a, we have y equals cosine of 3x squared. That squared is not squaring the whole function, it's just squaring within the stuff, the 3x. So, take the derivative. Y prime is equal to derivative of cosine is negative sine of 3x squared. Tack along the derivative of the stuff, which is going to be 6x. Therefore, my derivative, y prime, is equal to negative 6x sine of 3x squared. B. Y equals cosine 3 times x squared. Cosine of 3 just represents some number. So that's essentially just a coefficient. So all I need to do is take my derivative. Take the 2, multiply it out front. So y prime is equal to 2 times cosine 3 x, now to the first power because we subtracted 1. Or, looks a little bit nicer to write y prime is equal to 2x times cosine 3. Not too picky there. Okay, but it is important to recognize that the cosine of 3 is simply a number. Last in this group is c, which is y is equal to cosine 5x. What that means is my cosine x function is being raised to the 5th power if it's between the trig function and the actual variable. So we're going to use our power rule, come on, and the chain rule to differentiate. So when we take our power out front, y prime is equal to 5 times cosine x, drop it down 1 to the 4th power, times the derivative of the stuff, which is negative sine x, and clean it up a little bit, y prime is equal to negative 5 sine x cosine x to the 4th. Or we can write it y prime is equal to negative 5 sine x cosine 4th x. Two more problems and then we're done. Sometimes, unfortunately, we need to use the chain rule more than once. Like in this problem, f of x is equal to sine cubed of 4x. It's actually t's, but we'll fix that when we rewrite. So f of t, remember that third power there between the sine and the 4x means that we have sine of 4x. That whole thing is being raised to the third power. And that's not an x, it is a t. I'll get that fixed for you. T. Okay, so clearly we have the power rule, we've got stuff within stuff. So we're going to start by applying the power rule. Bring the 3 out front. F prime of t is equal to 3, leave everything else the same for now, sine of 4t. That now gets squared because we bring it down a power. Now, the chain rule says I need to tack along the derivative of the inside stuff. Well, the derivative of sine is cosine, so it's going to be cosine of 4t. But that derivative also requires the chain rule because there's a 4t, so tack along a 4. 3 and the 4 can multiply together. F prime of t is going to be equal to 12 sine squared of 4t cosine 4t. And we're done. One final problem. We want to find the equation of the line drawn tangent to our function f of x is equal to 3x cubed minus 1, all raised to the 4th power, at x equals 1. Now, we know that in order to write an equation, we need a point and a slope. We have half the point, meaning here x is equal to 1, so let's find the y value to complete that ordered pair. To find y, plug 1 in here for x, and when we do that, we get y is equal to 16. So there's my ordered pair. To find the slope, I need to find f prime of x. And my x value is specifically 1, so I need to find f prime of 1. So let's use some more algebraic notation. M is equal to f prime of 1. So let's find f prime of x. In order to compute f prime of x, I've got my power rule, but I also have stuff, so I need to use my chain rule. So f prime of x is equal to 4 times 3x cubed minus 1. Remember, don't change any of that stuff, just drag it along. Subtract 1 from your original power to make it the third power. And then we're going to tack along the derivative of the stuff, which is going to be 9x squared. Let's clean it up a little bit, so it's not too much algebra. F prime of x is equal to 36x squared times 3x cubed minus 1 raised to the third power. We're now going to find the slope when x is 1, so f prime of 1 is doing some auto-saving here. There we go. So we've got f prime of 1 is equal to 36 times 1 squared is 36 times 3 times 1 cubed is 3 minus 1 is 2, so 2 to the third. So f prime of 1 is equal to 288, which is my m value. I have my point, I have my slope, so let's write our equation. Y minus y1 equals m times x minus x1. Equation answer, y minus 16 equals 288 times x minus 1. And now we are officially done.